Metal extract from the ore. Metallurgy. This metallurgy is the topic talking about how do we extract the metal out from the ore. And this is called a metallurgy. And we have 4 steps. The first step, mining. The second step, milling. Third step, smelting. Fourth step, refining. Let's go step by step. Step number 1. How do you extract the mineral? Number 1, dig it up. So this is called excavating. Open cast mining, if the metal on the mineral on the surface. So if the metal is on the surface, you can just extract it by open cast mining. But in case if it is on the deep underground, then this will be more complex and this will be a more expensive method. And now the next step, milling. What is milling? Imagine when you have a piece of rock that is could be about 99% of it is sand and rock, and the remaining only 1% is the mineral that you want. So you really try to make have a method to separate that 99% of rock, clay, and the sand, so that you don't want to waste too much energy for the extract. So you try to remove as much of clay, sand, and the rock as possible to extract for that remaining 1% mineral. And the method are very, very greatly. It depends. For example, like in the olden days, those gold digger, they dig gold, they were using a sieve pan to sieve in the river, to sieve out the sand and the clay. That is one way, using a sieve. Another way, like iron. What's property of iron? Attract by magnet. So they can use magnetic. So in case if a rock more respond to magnetic, more attract to magnet, then you must have a higher iron content than the least one. So that is the way we can use magnetic as a way of separating. And then there is another way called froth flotation. Froth flotation, this is actually is the most common way, and this is in fact most mineral are not as plentiful as iron and aluminium. Most mineral will be very much like copper, less than 0.0 something percent. Very, very few. And in case if this is only have a 0.0 something percent, how you're going to extract that tiny bit out from the rock? That is we talk froth flotation. Now let's talk how do they do it. This is an interesting way. First of all, what they do is they're using a froth agent. This froth agent look very much like the detergent, the detergent that you put onto on washing dishes. And then once you put in those froth agent onto the water, then you start to stir it and you blow a bubble to it. Very much like the children, they blowing bubbles through a straw. So when you blow bubble to it, when you blow bubble into this mineral, now you will have many bubble. This will be bubbling. And then now what's special about this bubble? and all the mineral will stick to the bubble and flow up with the bubble. So you simply scoop up the bubble, that is the minerals can be concentrated. Because all minerals are a positive, negative ionic compound, this positive negativeness will stick to this frothing agent and be bubbling up. So now this way is an easy, cheap, economic way to concentrate the mineral, to extract those low concentration 0.0 something percent zinc, lead, copper, gold, silver, all using this way. So any other way? Aluminium, for example, they can dissolve in acid, and it's more commonly aluminium can dissolve in strong base. So they can put it on strong base to extract aluminium. Now student, after we talk this milling, what is milling? We try to use some simple physical method to separate out as much as those rock, clay, and sand, called gauge, so that we can do the next step. The next step is called smelting. Smelting is the step it requires more energy. When you come to this step, usually the mineral is already much higher concentrate. And now when we go talking smelting, we have to look back onto this activity series again, because this activity series does affect the extraction process. Now let's start. If you're on the lower group, the least reactive group, remember this one are quite easy to be separated out. So you can, using some simple heat decomposition, just like mercury or silver. In case if the mercury with oxygen, you just heat it by the Bunsen burner, then they will separate out. So this is a simple way. The lower the activity series, the easier to extract. When you're on the middle group which including the iron, the one that we talk, and copper, the one that we talk, and plus all other common metal. This one, commonly you require temperature. This is called chemical reduction. The chemical reduction, like you have to using the blast furnace to raise temperature to 1000 degrees to extract out. When you go to the most reactive metal, that is very difficult to extract. Besides you need temperature, you also require electricity, called the electrolysis, to separate out the metal, called electrolytic reduction, to separate out the metal from the mineral. So you can see on this smelting process, the most reactive metal are hard to extract. The least reactive metal are much easier to extract. And now let's go back onto our iron and copper, the middle group. And you will, based on this rule, which ones will be easier to extract and which ones will be hard to extract. You will expecting copper, they will be easier to extract 7,000 years ago, mankind extract copper from mineral malachite. So, because they only require moderate high temperature, you can burn it from a pottery kiln to achieve that temperature, about 800 degrees to 1,000 degrees. You'll be able to extract out copper. How about iron? Iron is a different story. 3,500 years ago, mankind extract iron, hematite. It requires higher temperature. How high? 1,600 degrees high, almost double the temperature. And realize when the time they melt, the bottom bit will be the molten iron. They will be reached about 80 to 95% pure. And they will, on this side, this is called slag. Slag is all the sand, clay, stone that does not dissolve. That usually we will throw it away.